Okay, 8.3 is using trig equations to get like a certain angle and going all the way around the unit circle. So you still want to set up like your triangle HOA, but you're going to be given a fraction and you want to figure out what triangle you need to use. So there's two standard ones, the 30, 60, 90 and the 45, 45, 90, which just describes the angles in the triangle. So anytime that you see a radical 3, you're going to be using this triangle. Anytime you see a radical 2, you're going to be using the 45. And then the other ones, there are some that are just like anytime you see sine or cosine equals 0 or 1 or negative 1, then you have to use just the corners here. Let's see. So right is 1, 0. Oops. Up is 0, 1, left is negative 1, 0, and down is 0, negative 1. So you're going to be using those if you can't find the trig function in your triangles. So remember, it goes cosine first and then sine. So if I had cosine equals 0, then I would have this guy and this guy, 90 degrees and 270. The other part of this that I want you to remember is where all the correct signs are in your unit circle. So remember, if you go right, it's positive, and up is also positive, and two positives make a positive. In this quadrant, so this is quadrant 1, in quadrant 2, if you go left, it's negative, and then up is positive, and they make a negative together. And then bottom one, you go left and down, that makes positive, and then the right one, you go right and down, which makes a negative. And these are always cosine, then sine, then tangent. So if I know tangent is negative, then I look here and here. And I would say those two quadrants. So it's better when you actually see a practice problem. So if you look here, we want to get that tangent alone or tangent angle alone. So it's already alone, and we're looking for negative 1. But that's not a fraction, so I'm going to put it over 1. So looking back at my triangles, the 45 was the only one that had O and A as the same. Remember, that was radical 2 and radical 2. They're the same, which means 1 over 1. So I know my angle is first going to be 45 degrees, but then I need to pay attention to the sign. So remember the plus, 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 minus, plus, minus, 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 plus, plus, minus, minus. Where's tangent? Negative. Tangent, negative. And that's here and here. So we're looking at only those two quadrants, quadrant 2 and 4. So I'm going to draw my triangle there. 45, 45. And then I want to know how far did I go from 0 to get to the diagonal. So that's 180 minus 45, which is 135. And then this, let's do a different color. Great. This to here was 360 minus 45, which gets you 315. And then the last thing you want to check is if you add or subtract 360 degrees, is it still within 0 to 360? And for those two answers, 315 and 135, if you add or subtract 360, it doesn't work. So you just keep those two. And that's it. So let's try one in radians. So if you look at problem 13, let's go back to a good color. Problem 13, our answer is going to be in pi. So you can either do that right at the beginning or at the end. It doesn't really matter. So the first thing you do is get tangent alone. So we have to move the negative 2, or the 2 over. And it's adding to the tangent. So we subtract. If it had been multiplying, we'd divide. So we get tan of negative angle equals 1, and this is okay. As long as it's in the parentheses, you don't have to do anything to it right now. We're going to make this a fraction over a, and we happen to do this one already. So we want a triangle where the O and the A are the same, which is a 45. And then looking at our quadrants, these two quadrants right here are the only times you get tangent as positive. So we're going to be looking at quadrant 1 and 3. So if I draw my triangles there, a 45 triangle, and I want to go to the diagonal, so to here, it's just 45. And then all the way to here, that's going to be 180 plus 45, so that's going to be 225. And then once you have those two, that's what this inside piece equals. So negative angle equals those two things. So then you do have to get the angle to not have the negative. So we're just going to switch all the signs here. So we get those two angles, but those are not from 0 to 360 or from 0 to 2 pi. So we're actually going to take our 360 and we're going to add it again to both of these and see if we can get a number inside. And we actually end up getting 315, and there we get 135, and those are both within our circle, so that's good. If I added it again, it doesn't work. It's not less than 360. And then the last thing is to change this to radians. So remember to change it to radians. You do pi over 180. So you're technically dividing both of these by 180, these two answers. So on this first one, we actually get 7 pi over 4 when you reduce it. And on the second one, we end up getting 3 pi over 4 when you reduce it. And so those are actually our final two answers because our problem asked for answers in pi. And that's it.